Friends, welcome you all in the video Bnf Notations. In our last video we have discussed what is the meaning of grammar, why the grammars are used, what is formal grammar. Now in this video we are going to discuss one terminology that is very much similar and that is very much related to the formal grammar, that is Bnf notation. So Bnf notation stands for Backus norm nor form. Backus nor form. So Backus and Nor, these are the computer scientists. They have developed certain notation for describing the formal representation of context-free grammar. So Bnf notation generally basically it is used for formal, or it is used to write formal representation of context-free grammar. It is also used to describe syntax of programming language. So syntax of programming language, because whenever we are going to compile the program, so during the compilation program, in the first phase of the compiler, our program, it is going to be passed through the syntax analyzer. In that particular phase, after producing the lexemes or set of tokens by the syntax analyzer, next stage is to check the validity of the syntax, validity of the lexemes, or validity of the tokens. So whatever the tokens produced by the lexical analyzer, they are correct or not. So for that purpose, we are going to use the context-free grammar. So in context-free grammar, the Bnf notations are basically used. So Bnf notation is basically just a variant of context-free grammar. So variant of context-free grammar, they are also called as variant of context-free grammar, BF notation. So now in Bnf notation, the productions have the form left side of production is derived by the definition. So these are the general notation for the productions. So left side derives the definition, where the left side may contain the set of terminals and non-terminals and definitions that will belong to production rules which are may be having terminal and non-terminal symbols. So like this. So in Bnf, left side contain one non-terminal in the left side. It will be derived by the definition or set of production rules. So this is the general representation of the Bnf notation. Now from that, we can define several productions with the same left side. All the productions are separated by a vertical symbol like this. Vertical symbol, we can say pipe symbol like that. So the basic representation in the Bnf notation is that left side contains non-terminal and right hand side will contain set of terminals and non-terminals that can be replaced by these production rules given for the particular grammar. So by using that particular symbol, we can define several productions with the same left side. All the productions are separated by a vertical symbol. There is a production, suppose for example, there is a production for any grammar like non-terminal s is derives, or can have the form of terminal symbol a, non-terminal s and a. So again the second derivation is that, so s derives to b, s of b, or s derives to c. So we can say that the s is a non-terminal and A and B and C are terminal symbols. So as per the definition of Bnf notation, we can represent this particular set of grammar like S can have or can derive like this. So all these notations, they are separated by the pipe symbol like this. So S can either be replaced by AS of A, BS of B, or C. So here A, B and C, these are non-terminals and S is a terminal. So S can be replaced by either AS of A, then S can be replaced by AS of B, or S can be replaced by C. So these are the set of terminal symbols and non-terminal symbols and production rule. So in the Bnf notations, they can be represented with the help of this vertical symbol like this. So S can have is the meaning of this particular vertical symbol is that S can have a form of AS of A, B and S of B and C, where small a, B and C, these are terminals and capital S is the non-terminal. Now coming to the next terminology, that is called as derivations. So what is derivation? So derivation is a sequence of production rules. So derivations are nothing but they are sequence of production rules. It is used to get the input stream through these production rules. So they are used to get the input stream from the production rules. During parsing, we have to take two decisions. Either we have to decide the non-terminal which is to be replaced. We have to decide the production rule by which non-terminal will be replaced. So during the parsing, the derivation process can be used. So in that derivation process consists of making the decisions. So in that decisions, the decisions can be made based on the particular scenario. So in that, either we have to decide the non-terminal which is to be replaced, or which production rule by which non-terminal should be replaced. So this is the general form of the derivation. So derivation is nothing but sequence of production rules. It is used to get the input string through these production rules. During the parsing, we have to take two decisions. These are like we have to decide the non-terminal which is to be replaced, and we have to decide the production rule by which the non-terminal should be replaced. So in this way, the derivation process can be have. We have two options to decide which non-terminal to be replaced with the production rule. So either we can use now this derivation, like they can be also classified into leftmost and rightmost derivation. So either we can have leftmost derivation or we can have rightmost derivation. What is the meaning of leftmost derivation? In the leftmost derivation, the input is scanned and replaced with the production rule from left to right. So leftmost derivation is nothing but in the leftmost derivation, the input is scanned and replaced with the production rule from left to right. So in the leftmost, we are going to move from left to right. So input is scanned and it is replaced with the production rule from left to right. So the leftmost derivation, we read the input stream from left to right. For example, so we are having the production rule S is equal to S plus S, or S can take the value of S minus S, where S is non-terminal and S can have the values of A, B and C. So suppose the input string is A minus B plus C, A minus B plus C. Now see the leftmost derivation process. So here in the leftmost derivation, so what is the given production rule is that S equal to S plus A. Then so here this is now consider this part of the derivation S equal to S plus A. So this S is in the left hand side and this S in the right hand side. So in the leftmost derivation, we start from left side of the derivation. So we can replace this as either s equal to s minus s, and then either we can replace them with the help of symbols a, b and c. So now, so we have replaced s is equal to this second production rule, s minus s plus s. Now after this, either in the third derivation, we can replace s either by a, b or c. So our input string is a minus b plus c. So we have replaced this s with the small non-terminal a minus s plus b. In the next derivation, this s is replaced by b and this s so is replaced by c. So in this way we get the input string a minus b plus c by using the leftmost order of derivation. So in the during the parse process, we require to replace the productions and derivations. So based on that production and derivation, either we can use leftmost derivation or rightmost derivation. So that derivation process is nothing but it is a sequence of production rule. It is used to get the input through the production rules. During parsing, we can take the decisions. Either we have to decide non-terminal to be replaced, or we can decide the production rule by which the non-terminal has to be replaced. So for that, we are having two options to replace the non-terminal. Either we can go for leftmost derivation or we can go for rightmost derivation. So in the leftmost derivation, the input is scanned and replaced with the production rule from left to right. So the input is scanned and replaced from left to right. So the leftmost derivation, we read the input string from left to right. So in the leftmost derivation, we read the input string from left to right. So suppose we are having a production rule s equal to s plus a, where s is non-terminal, small a, b, c are terminals. So s can take the form s equal to s minus s, and then s equal to a or b or c. S can take the value of a, comma b, comma c. So for the leftmost derivation, first we have to start with the first derivation, s equal to s plus a. So in this derivation, if we take this form, this particular form, so like this, the input string given is a minus b plus c. So we have to check whether this input string is derivable based on this production rule. So we have to check by using production rule either this input string is derivable or not. So we have seen that s equal to s plus a. So by taking this production rule, s plus s, so this s can be replaced by s minus s, or it can be replaced by the symbol either a, b or c. So as the leftmost order of derivation, we have to start from the leftmost part of the string. So we have started with this s. We have replaced this s by s minus s. Now after this, we are having no further derivation, like we have to replace s either by a, b or c. That's why we have replaced s by a. Then we are having the production rule s plus s. So that can be replaced by either b or c. So a minus b plus s. Now remaining symbol c is there. So we are going to replace this c like this. So we will get this s equal to a minus b plus c. So in this way, the leftmost order of derivation we have performed on the given input string to find out whether the input string, given input string, is derivable from the production rule. If it is derivable, so by using the leftmost order of derivation, we are replacing all these input strings one by one to obtain the input string like s equal to a minus b plus c. So When we are going to select the left part of the expression, then that particular part of the expression, that particular method, it is called as leftmost order of derivation. So in this video we have discussed leftmost order of derivation. In our next videos we are going to discuss regarding rightmost order and other terminologies related to the context-free grammar and formal languages.